Hello, my name's Andrew. I like to build stuff and rock climb. I thought it'd be cool to try to build my own camming device. So climbers in the 60s and 70s had to make all of their own gear, like pitons and nuts, and probably even cams at some point were all being built out of garages. I don't have a garage, but I have a spare bedroom with a bunch of tools in it. So I think I can give one of them a shot. So I've got a cam right here. And this is made by Black Diamond, super nice cam. It goes in a parallel crack, and when you fall on it and you pull outwards, it expands, and that's what keeps itself in the rock. This is one of the more complicated pieces of rock climbing equipment because pitons are just like pieces of metal, same thing with nuts. Cams are a little bit more complicated and definitely harder to make, so I thought I should try making one of these first. I'm going to do a quick overview of the boring engineering parts of this. So basically, I divided up the cam into three main parts: the lobe, the stem, and the thumb loop. So I'm going to first talk about how I made these lobes. So this is my CNC machine. I made it to cut materials like aluminum and steel that I couldn't easily do in other ways. You can load computer programs onto it based on CAD models, and it cuts the shape out you want. And it also does this very precisely. So I couldn't make things like this by hand without spending a lot of time. This just runs a program and makes exactly what I want. It takes a little bit of time and it's pretty noisy, but it definitely gets the job done. And yeah, once you clean up the mess that it makes of chips, you have finished parts. Next is the stem. I made it using my 3D printer. I can make rigid and flexible parts, so the flexible stem and the rigid trigger bar were both able to be 3D printed. Finally, for the weight-bearing thumb loop, I use this stuff called Dyneema. It's really cool because you can like finger trap it inside itself, and you can get basically full strength joints out of it. This is like really strong stuff, and it can hold a lot of force, which is really good because the thumb loop needs to hold the force of my fall. So it's a pretty simple procedure where you just thread it inside itself right here. And the reason I like this is because it's a lot simpler to just thread some cord inside of itself rather than crimping metal connections together, which was what I'd have to do if I used a steel cable. So this is a pretty good alternative. It does all of the weight, it's lighter, and yeah, it holds what I need to. And if you put all these things together, you have a nice camming unit. So here's the cam that I just built. It's got a Dyneema thumb loop, which goes all the way up and it wraps around this axle at the top, comes back down. This is where you clip. This is what you clip onto when you're gonna take a fall. I have these 4 lobes that all got milled on the CNC machine. 1, 2, 3, 4. And they are the correct shape. And then lastly, I have these 3D printed parts. So I have a stem and I have a trigger. And these are like non-life supporting parts of it. And all they do is the stem kind of protects the Dyneema sheath and allows it to bend around and that kind of stuff, which is kind of nice. So that like if you're over the side of a rock, it'll bend like that and get out of the way. And lastly, I have trigger wires, which I just broke, that when you pull them are supposed to move the lobes down like this, like on this one. Yeah, so I've got this cam right here, and in comparison to like the brand name Black Diamond one, it's definitely not as durable, it's not gonna last as long. Like there's several things about it that probably like it's not strong enough, it's heavier than this one, but I like this one a lot more. Like it's not even safe, but I made it myself. So to test this cam, I climbed up a route that I knew had the right size crack, and I placed my cam with a backup right below it, and then I was able to take my first small fall on it. It like moved a little bit, but it's still fine. Holding a small one is cool, but I think everyone wants to see some bigger falls now. No way, that actually held? Okay, let's try one bigger one. So I took 3 falls on this, and the damage is actually not as bad as I thought it was gonna be. So all of the napkin math checked out, and the axle held. The Dyneema held me, but I did notice down here we've got some slippage on the Dyneema. That's because I didn't stitch the correct amount of length into the Dyneema, because I needed a like 8-inch loop, and I'm using 3mm Dyneema, so I couldn't physically splice a long enough piece in there. So yeah, it's slipping, and that's not super surprising. I'm glad it held me though. Some wear on the lobes. You can kind of see there's like some indents that have been put in there by the rock. That's usually pretty expected, but this is a softer material than this, so on the used one, there's definitely no indents like there are on this one, a little side by side. The Dyneema loop definitely got longer the more I fell on it, so this is definitely slipping, and I shouldn't continue to use this. And you can also see around where the carabiner was, it's all torn up from the carabiner just like rubbing over it. So for the next version, I think that I'm gonna have to figure out some better trigger wires. The spring in here really isn't that stiff. Like it looks strong on camera, but if you feel it, it just feels wrong in comparison to this one, because this one has a lot stronger of a spring in there. And the thing is, strong springs take space, and I didn't design enough space into this one to put a strong spring in there. So no strong spring means it doesn't hold into the rock as well. Like when you're climbing, it'll like move on you, and it just feels wrong. And then lastly, you see how this one, when I squeeze it, the lobes kind of come all the way down and they cross each other. That's because you get the maximum range out of this one. This one, if I didn't break the trigger wires, only goes down to about here. So you're only getting like maybe 30% of the range of what the full lobe could do, and that's not ideal. I also realized that I used a 17-degree camming angle on this cam, and the industry standard is 13.75, so this one has a lot more range on it, but it doesn't hold into the rock as well. So if I wasn't climbing on some nice sticky, I guess not sticky, but like nice textured granite, it probably wouldn't hold me as well. So because I wasn't able to break this myself by falling on it, I'm gonna send it over to Ryan at How Not to see if he can actually do some heavier pulling on it and actually break this unit. I think the trigger wires are definitely going to be a problem for him setting it up, but it's not a big problem for when it's being pulled, because the trigger wires don't have any load on them. I think what's going to happen is the Dyneema is going to break, because like napkin math wise, the strength of the axle is super strong, and I'd be kind of surprised if he actually pulled through the aluminum on these. But I don't doubt he has a strong enough hydraulic cylinder for that. So this is definitely more expensive than this. I think I paid maybe 80 bucks for this cam, and it's all super nice. I think I paid about 120 bucks in materials for this one. I think, but most of the materials were kind of like spares and stuff to try out different like Dyneema for it. I think total cost of this one is probably around 30 bucks, maybe 40 of actual material in this. Yeah, but I would not want to make these more than one. So that's the cam. I guess it held. All right, I'm gonna take this and go have some fun.